Look closely at the universe, and you will find it doesn't operate by chance. From the orbit of galaxy clusters down to the boiling quantum foam, reality is bound together by strict, invisible mathematical rules. And sitting quietly at the base of those rules is a single, bizarre value. Physicists call it the fine structure constant, represented by the Greek letter alpha. Its value is approximately 1/137. This specific fraction sits at the intersection of modern physics. It combines the elementary charge from electromagnetism, Planck's constant from quantum mechanics, and the speed of light from relativity into a single, elegant ratio. What makes alpha so strange is that it is a dimensionless number. The speed of light changes depending on whether you measure it in miles per hour or meters per second. But with alpha, all units of measurement cancel out. You are left with a pure ratio. An alien civilization using an entirely different system of measurement would still arrive at the exact same number. This number commands a unique level of respect among scientists. Nobel laureate Richard Feynman described it as a magic number that comes to us with no understanding by man. We can measure alpha to astonishing precision, and we know it dictates the very structure of the universe. Yet there is no physical theory that explains why it has this specific value. Early theoretical physicists were so desperate for an answer that they tried to force one. Sir Arthur Eddington spent years employing obsessive numerology, trying to prove that 137 could be deduced purely by logic, without relying on physical experiments. But perhaps no one fell harder into the rabbit hole than Wolfgang Pauli. His relentless pursuit of the origin of 137 eventually triggered a profound psychological crisis. Pauli grew so desperate that he sought the help of the psychoanalyst Carl Jung. Together, they spent years trying to bridge the cold mechanics of quantum physics with the human unconscious, hoping the answer was buried in the mind itself. Years later, Pauli was admitted to a Zurich hospital with terminal cancer. When he arrived, he noticed the number on his door. He told his assistant he would never leave that room alive. He died there, in room 137. The search for 137 drove geniuses into mysticism, yet its practical utility remained hidden far beyond the mind, out among the stars. Deep inside the core of a burning star, alpha governs a specific interaction. It controls exactly how strongly charged particles repel or attract one another. For a star to create carbon, the building block for all biology, it has to execute the triple alpha process. It must force 3 helium nuclei together. Because these nuclei are all positively charged, they fiercely repel each other. They only overcome this repulsion because of the Hoyle resonance. It is a highly specific energy state, governed entirely by the fine structure constant, that allows these 3 nuclei to lock together and stabilize into carbon. This is a razor-thin margin. If the value of alpha were altered by even a fraction, say 1/138 instead of 1/137, this resonance would fail. The nuclei would shatter apart. Stars would be unable to synthesize carbon, leaving a cold, sterile universe. This brings us to the anthropic principle. Does the universe possess this exact value because it was meticulously tuned for life, or are we simply the beneficiaries of a random cosmic dice roll? To find out, modern physicists have stopped relying on numerology. Using lasers and supercooled atoms in total vacuums, researchers can now measure alpha to parts per trillion precision. Those measurements revealed a twist. This chart shows the value of alpha plotted against energy levels. The line doesn't stay flat. Under extreme conditions, it arcs upward. Alpha is not a fixed, immutable constant. At high energy scales, like the environments inside particle colliders or the immediate aftermath of the Big Bang, the strength of electromagnetism actually changes. The constant shifts away from the 137 baseline. Since these physical laws shift under extreme heat, we have to ask what happens in the freezing, ancient vacuum of deep space. To find out, astronomers use massive telescope arrays to peer backward in time, studying light from quasars up to 13 billion light-years away. By analyzing light absorbed by ancient molecules, scientists can measure the strength of electromagnetism in the early universe. They look for subtle shifts in these absorption lines, chemical fingerprints that would prove alpha was different billions of years ago. recent observations have revealed evidence for a spatial dipole. The data suggests that the value of alpha physically varies depending on where you look. It appears slightly higher in one direction of the universe and lower in the opposite. If these cosmic fluctuations are verified, it breaks the standard model of physics. It proves that the laws of nature are not universal, but vary depending on your coordinates in space. 1/137th dictates how stars burn and how life forms. This ratio is the thread holding our reality together, pointing toward a hidden architecture of the cosmos.